everyone. So let's begin with problems from today's Leetcode contest. So the first problem. So the first problem states that you are given an integer array nums and we consider an array good if it is a permutation of an array base n. And how do we define the array base n? So it comprises of all the numbers from 1 to n and the number n is repeated twice. Okay, and here are a few examples. And we have to find whether the given array nums is a good array or not. Okay, so let's consider an example. So this third example, so the numbers are 3, 4, 4, 1, 2, and 1. So there are 6 numbers in this array. So if this is a good array, then what should be the base array whose permutation is an array of length 6. Okay, so that array should comprise of 5 elements, that is 1, 2, 3, 4, and 5 should repeat twice. Then only we can achieve the base array of length equal to 6. Okay. So now we can simply check whether all these numbers are present in this array or not. And if it is present, then what is the frequency of each number? For example, 1 is present once in the base array, but here it is present twice. So we can simply say that it is not a permutation of the base array. Otherwise, we can also see that 5 is repeated twice, which is not present in this array. So this is not a base array. So let's have a look at the code. So simply I've calculated the length using the nums.length and I've stored the value of n minus 1 in a variable k. So why did I need this variable? Because the length minus 1 is the largest number that is present in the base array. And this number is repeated twice. Okay. So the value of k is the largest number in the base array which is repeated twice. Okay. So the length of the base array would be equal to k plus 1. So is the length of the array given. And I've iterated over all the values present in the nums array. And if that value is greater than k, my array has some value, let's say in this case 10 or 6, then I can simply stop iterating and say that it is not a possible answer because 6 and 10 are clearly out of bound of this range from 1 to 5. Okay, so I can simply return false in that case. Otherwise, I can store the frequency of that element by going to the given index equal to the value of the value and incrementing it by 1. And after that, I need to check whether from 1 to k minus 1, all the elements have frequency 1. And if not, then return false. And whether the kth element has frequency 2. If not, then return false, otherwise return true. Okay. So this was the first problem. So let's have a look at the second problem. In the second problem, it is stated that we are given a zero-indexed integer string s and permute s to get a new string t such that all consonants remain in their original place. More formally, index I where I lies between 0 to the length of the string. Then if si is a consonant, then ti will also be a consonant. That means the position of the consonant must not change. However, the vowels must be sorted in non-decreasing order in the array. Okay, so pretty easy problem. And how can we approach it? We can iterate from the start, store all the vowels, sort them, and place them at the positions where vowels are present. So if we see the first example, L, E, E, T, C, D. Okay. So I'll separate all the vowels out. I'll store it in a separate array. I'll sort them based on ASCII value. Simply arrays.sort will do this on basis of ASCII value itself. And once I'm done with it, I'll again iterate on the string from the start and check whether a vowel is present at the given index or not. And if I find a vowel, I can keep a pointer here. I can replace it with the vowel present at this index, at the first index of the sorted array. After that, I'll move the pointer forward and I'll continue iterating in this array until I find the next vowel. Once I'll find the next vowel, I will replace it with this character, that is O, and move the pointer one forward. Once done with this, I'll continue iterating forward, find the next vowel, replace it, and move the pointer forward. And when I find the last vowel, I'll repeat the same process. And once all the vowels get updated, I will reach till the end of the sorted list of arrays. And the new string thus formed is my answer. And I can return that. So here's the code. I've stored all the vowels in a set to check whether the given character is a vowel or not, which I've used later. So and I've stored the string in the form of a array in the array ARR. And to store the vowels, I've used array list L1. And I've iterated over all the characters of the string. And if that is a vowel, then I've added it in the list. And then I've sorted the list based on ASCII values. And I've kept a pointer, as I mentioned, at the start. And once I've placed one vowel, I'll move the pointer one step forward. So I'm again iterating from the start. And if the current index had a vowel, then I'll place it with the new vowel from the sorted list and increment the pointer by 1. At the end, I've concatenated all the characters and returned it as my answer. So this was the solution to the second problem. So here's the third problem. So the third problem states that you're given a zero index integer array nums and a positive integer x. You're initially at position 0 in the array, and you can visit other positions according to the following rules. So what are the rules? I can visit an index j, which and j should be greater than I if I want to visit index j. And for each position I that I visit, I have to add nums of I to my answer. Okay, so my score will be incremented by nums of I. And if there is a change in parity while moving from index I to index j, then I'll incur a penalty of x. So what does that mean? That if I was initially at a position which had an odd value, and now I'm jumping at a position which has an even value, then I'll incur a penalty of x for each such jump. I will obtain the value. I will add I'll update my answer with the value present at this index, but I will also incur a penalty of x. Okay. So we can simply write a recursion solution, and after that we can apply dp to solve this. So what can we do? So let's assume that we are at some position. Let's assume that index as I. Okay. So I have two choices while I am at index I. I can take this value. I can take the value present at index I, or I can ignore it. Okay. So let's assume that before I selected index I was at some index, let's assume j, and j had a parity of, let's say, p. The parity of j is p. That is, if j is even, then p is 0. Otherwise, if j is odd, then P is 1. Okay. So once I'm at index I, which I've jumped from index j, so I have two choices. I can move on to index I plus 1 without selecting the value at index I. And so my parity of the previous selected index would not change. So it would still remain equal to P. Otherwise, I can select I and then jump to any other element, to the next element. Okay. And now, how will I decide the parity? So I said that parity would be 0 in case of even and 1 in case of odd. So the value present at the ith index, let's say ARR of I or nums of I, modulo 2 would give me the parity that I need to check while selecting the next index. Okay. And while I'm selecting this answer, there can be two possibilities. That the parity of the current element is equal to ARR of I modulo 2, and the parity of the previous element that I received was P. Okay. So if both of them are equal, then I'll not incur any penalty. And if both of them are not equal, then I'll incur a penalty of X. Okay. So so this is the recursive solution, and then I can apply DP on it. So DP will have only two states, that will correspond to index and the parity of the previous element. And this has only two choices, that is either 0 or 1. And the index can go up to the entire length, which is equal to nums.length, so that can go up to 10 to the power 5. So let's assume that the length to be n, so that can go up to n. So the DP would have a size of 2 times n. So the space complexity would be equal to big of 2 times n. And the time complexity would also be equal to big of 2 times n after applying D. So let's have a look at the code. So here's the code. So it has been mentioned that I am initially present at nums of 0. So I can begin from index 1. And my parity of the previous element would be equal to 0 if the element at the 0th index is even, or it would be equal to 1 if the element at the 0th index is 1. Okay. So this is the recursive solution. If my current index is greater than or equal to the length of the array, then I can simply return 0. If that value is computed before and stored in the DP, then I can return that value. Otherwise, I have two choices, either to skip this value, or I can select this value and add the amount to the answer and subtract a value equal to X in case there is a change in parity from the last index, between last index and the current index. And the maximum out of the two is returned and also stored in the DP, and might be used for further recursive calls. Okay, so this was the third problem. So let's have a look at the fourth problem. So in the fourth problem, there are two positive integers n and x, and we need to return the number of ways n can be expressed as the sum of xth power of unique positive integers. In other words, the number of sets of unique integers n1, n2 up to nk, where n equal to n1 to the power x plus n2 to the power x up to nk to the power x. And we have to return the answer modulo 10 to the power 9 plus 7. Okay, so here's an example. So 160 can be represented as 2q plus 3q plus 5q. Okay. So here's another example, that 10 can only be expressed as 3 square plus 1 square. So we can see that repetition is not allowed in any case. it is we cannot make 10 by this combination, by taking 1 square twice and taking 2 square twice. So this is not allowed. So each number that I select must be unique. Okay. And if you have a look at the constraints, we can see that n ranges only up to 300. So what is the largest number that I'll require to constitute to create my answer would be 300. Okay, because 300 x dies between 1 to 5 and 300 to the power 1 can only give me 300. Okay, so 300 is the largest number that I require to create my answer. Okay, so how can I proceed? Let's assume that I've been given a value of x. Okay, and I know that I need to create the sum equal to n. Okay, let me create an array of size n. Index 1 as 1, 2 as 2, 3 as 3, and the nth index as n. And here I store the value of 1 to the power x, 2 to the power x, 3 to the power x, and the last one as n to the power x. So if I simply iterate from the start and keep subtracting or not subtracting a value from this array until I obtain a value of 0 or something less than 0, then I can calculate the total number of ways to create the given sum. So for example, if x is equal to 2, x equal to 2 and the value of n equal to 10, okay, and my array would look something like 1, 4, 9, 16. So I don't need up to 10 because I can see that 4 square is itself greater than 10. So I won't need all the elements up to 10 square. Okay. So I'm beginning from the 0th index and my current value equal to 10. Okay. So I have two choices. Either I can subtract 1 from it or not subtract 1 from it. Okay. If I decide to subtract 1, I'll be left with 9. Otherwise, I'll be left with 10. Okay. Now I move to the next index. Here also I again have two choices. Either I can subtract or I can not subtract. If I decide to subtract, then I'll be left with 5, 9. And similarly, if I did not choose the first element, and however I decide to choose the second element, then here's 6. And if I decide to reject both, then I would still have 10. And the third element. And now I move to the third index, that is the index 3, having the value of 3 to the power x, that is 3 square 9. And if I subtract 9 from this, I'll be left with a value less than 0. Okay. So what can I conclude? I can conclude that after subtract that 1 square plus 2 square plus 3 square, that is selecting all of them, would definitely not give me an answer. Okay, because this path was corresponding to that itself. It had -1, -4, and -9, and that resulted in a value that was less than 0. Okay, so this is not my answer. So this will return 0. Okay. Similarly, if I follow this path, I have two choices, that I'll subtract 9. That would give me a value 0. Or I won't subtract 9. That would still keep the value as 9. Okay. So here I obtained a value equal to 0. So what can I say? That following this path gave me a value equal to 0. That means subtracting the first element from 10, not subtracting the second element from 10, and then subtracting the third element from 10 resulted in a value of 0. Okay. So that means 3 square plus 1 square would be equal to 10. So this is one of my possible answers. So this will return 1. Fine. And in this case also, we can see that if I subtract 9, that would result in a value less than 0. So this should return 0. And if I don't subtract, I'll be left with 6. Here also, if I subtract 9, I'll be left with 1. If I don't subtract 9, I'll still be left with 10. Okay. So I can continue this up to 10 and see that how many times I'm getting 0. And every time I get a value equal to 0, I can return 1. Otherwise, if the value I obtain is less than 0, or I exceed the length of the array, then I can simply return 0. Okay. And once I've done with the recursive solution, I can apply DP to solve this, to optimize this further. Okay. So here's the code. So I can store the value of 1 to the power x, 2 to the power x, up to n to the power x in the array ARR, which has a length equal to n plus 1 because I'm starting from index 1, and I'm initializing all the elements of the DP equal to -1. Okay, and I'm storing all the elements of type 1 to the power x, 2 to the power x in the array ARR, and then I'm calculating my answer in the function called func. So in this function, the first check is that if I get my value equal to 0, then I need to return 1. Or if my index exceeds the length of the array, or if my value obtained is less than 0, then simply return 0. Okay, and these are the two possible steps that I can take. So what are they? I can simply ignore that element and move on to the next element, or I can select that element, and if I select that element, my value would reduce by ARR of 8. Okay, and I can simply return the total number of steps, that is equal to k1 plus k2 until for all the elements until I obtain my answer. Okay, and since I'm using DP and this is the maximum size possible, so it would be probably n into n. So the size of the DP should be n into n. So the solution is of big of n square, and in the worst case, assuming that the value of x equal to 1. Otherwise, I can stop at a step much before that, because here I can see that going up to 10 doesn't make much sense, because 4 square is itself greater than 10. So subtracting anything greater than or equal to 4 square would definitely result in a value less than 0. But in worst case, if the value of x is equal to 1, then I need to go up to 10 to calculate to get all of my answers. Okay, so once I'm done with that, so in worst case, the space I'll require would be equal to n square, and my time complexity would also be equal to big of n square. And since n is less than or equal to 300, so it will work.